Hello, this is Mr. Huber. In this lesson, we're going to be learning about ratios and proportions. First, what is a ratio? A ratio is just comparing any two quantities, and it can be written in one of three ways. So we're going to see here, A and B just represent the quantities, right? Variables, it could represent numbers. Typically, we're going to write these ratios with actual numbers, but it could be any number A to B, right? We could write a ratio, A to B. We're comparing A to B, whatever those quantities are. We can write this like it reads A to B with a colon in the middle, or as a fraction. And we're going to see the fraction is one of the more common things we're going to use to write our ratios, because we can then write what's called a proportion. We'll see in a little bit. Okay, so A to B can be written as A to B or A to B. So also when we're writing ratios, we want to write them in simplest form. Just like we'd reduce a fraction, we can reduce a ratio into its simplest form. Let's see how we can write some ratios for a couple of problems here. A volleyball team plays 14 home matches and 10 away matches. We want to write the ratio of home matches to away matches. Pay attention to the order. We want to write in the order that we're being asked, home to away. So home matches is 14. To away matches is 10. I'm going to write this one with the colon. If you wrote it as a fraction or with the word to, that's fine as well. We do want to simplify this. Just like we would simplify with a fraction if we wrote it as 14 over 10, we want to see do they have any common factors. They do. We can divide these both by 2 and get 7 to 5. So the ratio of home matches to away matches is 7 to 5. Now we want to write a ratio of home matches to all matches. So the home matches are 14. All matches is 24, right? We'd add the 14 and 10 to get the total matches they've played. And here I wrote it as a fraction. Okay, that's fine. We can see it written this way. And this would be equal to, if we simplify it, right, again, we could divide both these by 2 and get 7 to 12. So the ratio of home matches to all matches is 7 to 12. Right, so ratios, comparing two quantities, and we could write them in a couple different ways, make sure we're simplifying them for our final answers. In this example, we're going to see Derek and his brother combining their sneaker collections. They have a lot of sneakers here. Must be quite the collectors. Derek has 44 pairs and his brother has 52. We want to find the ratios that are asked for here. First, the number of Derek's sneakers to his brother's. Derek has 44 sneakers to his brother's 52. If we simplify this, and you might not find the biggest common factor at first, that's okay. Let's say you said, oh, I can divide these both by 2 because I know they're both even numbers. And you get 22 to 26. We could simplify that further. We could divide these both by 2 again and get 11 to 13. Or you could have used the common factor of 4 and divide these both by 4 and get 11 to 13. That's okay. Just make sure you simplify all the way. So 11 to 13, that'd be the ratio of Derek's sneakers to his brother's. Next, we want to write a ratio for the number of Derek's sneakers to the number of sneakers in the entire collection. So the number of Derek's sneakers is 44. To the entire collection, we'd add those together, get 96. Okay, so let's see if we can divide these both by 4 again. So if I do 44 divided by 4, I get 11. And 96 divided by 4 is 24. 11 to 24, again, if you simplified by a factor of 2 at first and then do that again, that works. 11 to 24, that's the number of Derek sneakers to sneakers in the entire collection. Now let's talk about proportions. I mentioned it earlier. A proportion is an equation stating that two ratios are equivalent to each other. So a proportion is comparing two ratios equal to each other. We can see some examples here, and we're going to solve them. So here we have a ratio. 11 to 6 is a ratio. X to 30 is a ratio. A proportion is when we put them equal to each other. If we wanted to solve this for x, what's happening to the x? It's being divided by 30. So we could look at this and go, what's the opposite of that? The inverse, right? Solve with inverse operations. We could multiply by 30 on both sides. That would cancel out on the right side. And over here, 30 over 1 times 11 over 6. We want to make sure we know how to multiply these fractions. We can simplify the 6 and the 30 to 1 and 5. So we have 5 times 11 is 55 equals x. So that gives us our value for the variable x. We can multiply by the 30. Solve that just like we would any other time. Again, we're going to get 55 in that case, and we could check it by plugging it back in and seeing if 11 over 6 equals 55 over 30. And we'd find out our answer is right, check it, see that it works back in the original equation. In this case, the equation is called a proportion because it's two equal fractions. In number 4, we have w over 35 equals 4 over 7. So by now you should be trying this and seeing if you know how to solve this one, and then play the video and see if you've done it correctly. So we want to multiply by 35 on both sides because w divided by 35, the inverse of that is multiplying by 35. So what w equals, and over here 35 over 1, and we can simplify before we multiply again, so we'd have 7 and 35 reduced to 1 and 5. 4 times 5 is 20, so w equals 20. And then in the third example there, number 5, we can multiply by 12 on both sides. Okay? The 12's cancel, that gives us the m all by itself. And we can make that over 1, that becomes 12 and 2 reduced to 1 and 6. 6 times 9 is 54. M equals 54. Right? So we can see how to solve a proportion by getting the variable by itself anytime we're solving an equation. We want to get the variable isolated by itself to find out what its value is, what it's equal to. Well, we have two equal fractions, okay, a proportion. We want to keep in mind their cross products are equal. So what does cross products mean? Okay, cross products are where we take the numerator and denominator from each of the two fractions and multiply them. So product means multiply. So 1 times 10 is 10. Then we have the other cross product, 2 times 5 is 10. The cross products will be equal, right? 1/2 is equal to 5/10. And the cross products will be equal. Anytime you have two equal fractions, the cross products will be equal to each other. We can use that to help us solve proportions as well. It's another method. And sometimes it's a method we'd want to use different than like the example we see here, 9 over 2 equals m over 12. We just saw that. We multiplied by 12 on both sides. You can certainly do that. You can also use cross products. Okay? 2 times m is 2m equals the other cross product, which is 9 times 12, which is 108. And if we divide both sides by 2, right, to cancel that out and get m by itself equals 54. It's the same answer we got previously when we had that same proportion. Okay, so cross products are equal is another method that can be used to solve them, and it's just something good to know that's true about any time you have two equal fractions. Okay, when you have a proportion, their cross products will always be equal. Before we move on to some more problems and applications, a little ray of sunshine here. Let's brighten your day. Cadillac Mountain. It's located in Maine. It's the first place that sees the sunrise in the United States each morning. So the very first place, you go to the top of Cadillac Mountain, and this picture taken from the top of Cadillac Mountain, seeing the sunrise, the first place anywhere in the U.S. that sees it. Pretty popular as a lot of people head up there early, get there to see that sunrise, break through the clouds, and start the day. Let's use some proportions to solve some application in real-world situations here. Okay, so number 6. A recipe of tomato salsa calls for 30 tomatoes to make 12 pints of salsa. How many tomatoes are needed to make 4 pints of salsa? So we want to write a ratio from our first situation. We're told here that 30 tomatoes to make 12 pints of salsa. So we're going to have 30 tomatoes to make 12 pints of salsa. When we write the other side of our proportion, we want to be consistent. We want to have tomatoes over pints. That's going to be one of your keys to writing a good proportion. Be consistent with what you're putting in the numerator and denominator. If it's tomato over pints on the left side, on the right side we need to have tomatoes over pints. And so 30 tomatoes to 12 pints, we want to know that would be equal to, when we make 4 pints, where's that going to go? That's going to go right here, 4 pints. How many tomatoes? That's what we don't know. That will be our variable. So some number of tomatoes to make 4 pints. And now we could solve this proportion. We could solve this to get the x by itself. We could multiply by 4 on both sides, or you could use cross products. We'll do that in another example so we can see how that works. But here the 4 cancels with the 4. So we're going to have x by itself. This is 4 over 1. And again, we can simplify that here before we multiply. We'll make that a 1 and a 3. So we have 30 over 3, which is 10. So we need 10 tomatoes to make the 4 pints of salsa. Right? So set up your proportion. Make sure when you write your ratio, you're paying attention to the units, you're consistent with how you're writing the ratio on both sides of that proportion. In number 7 here, we have an elevator taking the passengers from the lobby of the John Hancock Center in Chicago all the way to the observation level. It travels 150 feet every 5 seconds. So we want to figure out how long is it going to take to get to the observation level that's on the 94th floor, which is over 1,000 feet above the ground. So in order to solve this, we're going to take our ratio 150 feet in 5 seconds. So we have 150 feet in 5 seconds. And that's going to be equal to, again, now we need to have feet over seconds. Make sure we're consistent there. And so we want to know how much time is it going to take? How long is it going to take? That's our x, to travel 1,029 feet. 1,029 feet. So in this instance, we might be going, well, how do I solve for the x? Right? I've got an x in a denominator here. Right? This might be more challenging because the x isn't up here. I can't just multiply by something to cancel it out. This is where cross products could be useful. So I can take the cross products. 150 times x is 150x, okay? And that's equal to 5 times 1,029. So cross products, remember they're called cross products because we're multiplying, in this case 5 times 1,029, that gives us 5,145. And then we can divide that, right? We have 150x, so we can solve this by dividing by 150 on both sides. And it comes out to 34.3, so a little over 34 seconds. We'll put 34.3 seconds. Okay? Take a little over 34 seconds to get from the lobby up to that observation level. So write out your ratios, being consistent with your numerator and denominator, and then to solve, we've seen a couple methods now we can use to solve proportion, two equal ratios. One more here. And again, maybe try this one and we should be seeing how we're doing and setting up and solving a proportion for this situation. When 2 full moons appear in the same month, the second one's called a blue moon. Okay? On average, there are 2 blue moons every 5 years. So we want to find the ratio from that will give us the number of blue moons that are likely to occur in the next 25 years. So again, we always want to start with the ratio we know. 2 blue moons every 5 years. So we could write that out. 2 moons every 5 years is equal to, again, on this side, we're going to put the blue moons in years. So in 25 years, we're going to figure out that's X number of blue moons. You could solve this either way you wanted, cross products or multiply by 25 on both sides. So if you multiply by 25 on both sides, okay, that cancels out and it gives us the X by itself. 25 over 1, that would be 1, and 5, that would be 10 blue moons. So 10 blue moons would be expected in 25 years. If you did the cross products, let's look at it. We do 2 times 25, that's 50, equals 5 times x, 5x. So we would have ended up with, do that real quick, 50 equals 5x, the cross products, right? 2 times 25, 5 times x. Then we divide by 5 on both sides, and we get 10 equals x. The same answer, we'd still get 10 blue moons. So you can solve it either way. And we're going to see as we go forward, there are other instances where the cross products can be sometimes more useful, but if it's set up as we see here, you can use either method you want. So ratios, going back to the beginning, comparing two quantities, as we said, we're going to write them as fractions more often than not, but there are those 3 ways to write it. But especially when we're writing a proportion, we want to do it in fraction form. So ratio, comparing two quantities, make sure we're simplifying it when we can, and then using ratios that are equal to each other to set up a proportion to be able to solve for some information, whether it's a proportion given to us, solve for the variable, or those application problems where we can write ratios that are consistent and equal to each other to then solve for some missing information.